Hello! In this tutorial, I'll provide some key information related to scheduled natural ventilation simulations, outside air infiltration, and finally, I'll run a simulation and review some of the key results. Ventilation is the deliberate introduction of outdoor air, generally to meet the respiratory needs of the building occupants, but it can also be used as a means of providing cooling. This can be achieved either naturally or mechanically. Natural ventilation systems introduce outdoor air via openings in the building fabric, i.e. windows, vents and doors, which can be controlled according to temperature set points and operating schedules in the simulation. Infiltration is the unintentional and therefore uncontrolled airflow through the cracks, gaps and the porosity in the building fabric and openings. I will show you how to define these in the tutorial and will use the Design Builder tutorial example model. There are two general approaches to natural ventilation and infiltration modelling in Design Builder, depending on the settings selected here in the model options under the natural ventilation and infiltration header. The default scheduled option is generally used for early stage modelling. It uses typical assumed ventilation rates for the building type and is the fastest and easiest method to set up and run. All the previous tutorials have used the scheduled natural ventilation option when undertaking simulations. Calculated natural ventilation is more advanced and will be covered in the next tutorial. This option is more accurate over a wider range of applications, such as summer overheating analysis in naturally ventilated buildings. That increasingly requires the modeller to follow specific overheating risk methodologies, such as CIBSE TM59. These are not covered in this tutorial, but you can find guidance in the programme help. Infiltration rates can be specified using one of 4 different units. I will leave the unit selected to air changes per hour. Going to the Advanced tab, the option to model airflow through holes and virtual partitions is selected by default. You will need to tick the option under the scheduled header if you wish to model airflows through internal windows, doors and vents. As you might imagine, aspects of a building design that can impact natural ventilation are spread across several areas of a model and its data inputs, bringing into play the HVAC, activity and construction tabs when using scheduled natural ventilation. I will now go through the steps required in each area of the model to set up a scheduled natural ventilation simulation. You must ensure the site location and weather file are correct. I will leave these at default. For this tutorial, I will assume that this building has a radiator heating, boiler hot water system with natural ventilation, which I will select from the HVAC template list here in the HVAC tab. You will notice that the mechanical ventilation and cooling options have now been switched off, and the natural ventilation option has been switched on. You can consider this natural ventilation checkbox in the HVAC tab like a main on-off switch for the natural ventilation system. If it is switched off, then other natural ventilation inputs may not be used and/or displayed. So if you can't see a natural ventilation input that you expect to see, check that natural ventilation is switched on here. Scheduled natural ventilation rates are predefined using a maximum air change rate, which is controlled and modified according to operating schedules and temperature set points in the Activity tab. You can specify the method used to define the maximum outside air delivery rate here. I will leave it set to by zone and set the peak ventilation rate to 10 air changes per hour. This would be the maximum ventilation rate used by the model at full occupancy. Although 10 air changes seems high, it may occur in a real building if it is windy and your windows are open. The operation schedule here is used to modify this maximum design natural flow volume rate. For example, at lower occupancy periods, such as the start and end of day, the specified ventilation rate will be reduced according to the percentage occupancy at that time. On the Activity tab, you can control the operation of natural ventilation based on the indoor temperature set points by defining the options here. In the ventilation set point temperature header, I will change the natural ventilation minimum temperature set point to 23 degrees Celsius. Therefore, natural ventilation will be switched on only when the indoor temperature is above 23 degrees Celsius. You can also use detailed schedules and/or Design Builder scripting tools to enable more advanced temperature controls for the activation of natural ventilation. Scheduled natural ventilation is primarily for simple and early stage modelling, so these may be more useful with calculated natural ventilation. In this tutorial, I will use a natural ventilation set point 2 degrees Celsius higher than the heating set point. This should provide a significant deadband to prevent simultaneous heating and venting. I will change the heating set point to 21 degrees Celsius. The cooling set point is irrelevant as cooling is switched off in the HVAC tab. Going to the Construction tab, you can see that the infiltration rate is set to a fixed value of 0.7 air changes per hour. This value can be set by you. Infiltration can be switched off entirely, but that should only be done with caution, as it can have a big impact on results for anything other than very airtight buildings. The infiltration rate should be appropriate for the building age and type. Assuming that this is a new build, I will set the value to 0.4 air changes per hour. You can select different infiltration units in model options for compliance with specific certification or Passive House standards, for example. I will now run a simulation for 11th to 13th March with hourly and sub-hourly results selected, so we can review selected results relative to natural ventilation. I will change the time steps to 6 and run the simulation. I will go to the ground floor east zone and view hourly results. Notice that the zone air temperature has this relatively flat line, indicating it is being controlled. Here, the natural ventilation is working to keep the temperature down to our set point of 23 degrees Celsius. Looking at the total fresh air graph at the bottom, you can see that the infiltration provides a constant and uncontrolled air change rate of about 0.4 air changes per hour. The fresh air natural ventilation rate increases above this during occupancy, once the natural ventilation minimum temperature set points is reached. If you switch to sub-hourly results, you can get a much better sense of the variability of the airflow throughout the day. The heat balance graph shows the correlation between the ventilation rate and the associated removal of heat, i.e., the cooling effect from natural ventilation. Here we have a little bit of simultaneous heating and venting, shown by this small spike. If you want to eliminate that, you can increase the gap between the heating set point and natural ventilation cooling set point, or adjust the other controls as necessary. This finishes our quick review of scheduled natural ventilation and infiltration in Design Builder. If you want to learn more about the topics introduced in this tutorial, including top tips that will improve your modelling efficiency, then our Natural Ventilation and Infiltration on-demand online training session explores this in more detail. We hope you found this tutorial useful. Further information on the specific topics and wider application areas can be found in the comprehensive Design Builder program help, other tutorials and webinars, and our on-demand training.